So I've actually had a couple questions on problem 2. It's not as complicated as some people are reading into it. So I'm actually just going to go to the answer key that I have posted for this one. So the whole idea here is, so the question is, draw all possible products of the following aldol reactions. Assume that the ketones behave only as nucleophiles in the presence of aldehydes. So that means that the aldehydes can always act as nucleophiles. And then when you have a ketone, that they only act as nucleophiles and not electrophiles. So here the enol form of acetaldehyde is this, and then this becomes the nucleophilic position, and then the enol form of this, is this, and then this becomes the nucleophilic position. Alright, and so the whole idea behind this is that this molecule will act as a nucleophile both with acetaldehyde and with the propionaldehyde, and then this will act as a nucleophile both with propionaldehyde and acetaldehyde. And so if you look at it that way, then you can rationalize why you get 4 different products from this. You'll get self-addition of acetaldehyde to itself. The enol form of acetaldehyde will react with acetaldehyde. So in this case, this is the nucleophile, this is the electrophile. And then acetaldehyde will also react with propionaldehyde. And then also propionaldehyde will react with itself and acetaldehyde. So that's your permutation of your 4 different molecules. And I'm not going to go through B, C, and D because I think that it's pretty easy to step through the logic on these. There's nothing that's overly complicated here. One of the tricks on D here is that you'll have to realize that this cannot form an enol because that's already a quaternary center. This also cannot form an enol, so you can't form an enol at that position or at that position because you already have 4 bonds to the carbons, which would form the enols. Okay, and then past that, it's pretty straightforward.